So a function is simply a relationship between a set of variables. And this week, in the discussion, you're going to create a function. Now, the example that I've provided you here, which you can use, or you can, better yet, find something a little bit different. We're going to talk about weight gain or loss as a consequence of eating and drinking. Now, it seems reasonable that the amount of weight gain or lost is related to the number of calories consumed by food and drink or not consumed, right? So this is the relationship here. Now, there are other factors than just eating and drinking, but we'll ignore them for the purpose of our discussion. Now, food and drink contain calories, and so in general, we can state fairly accurately that weight gain or loss is a function of the number of calories consumed. But it's not just the number of calories consumed, it's also the number of calories that you burn, either through moving about or exercising or playing sports or whatever. And then there is also the case that animals' bodies, right? It doesn't have to be just humans, but bodies burn a certain number of calories just to keep themselves going, right? So even if you were to do nothing else but just keep lying down in bed, you would still be burning calories. And so that's what we also need to include. Actually, a significant number of calories are burned because of what is called the resting metabolic rate. Anyway, for the purpose of our discussion, we can say that, let me see if I can highlight this. Right here, that weight is a function of the number of calories consumed and the number of calories burnt. Okay, so we started out back here with simply a single function, right? Let me just erase this from the screen here. I guess it's easier to do it this way. A single function, and now we've got two functions. Weight is a function of both the calories consumed and the calories burnt. And those two functions were subsumed within this single function here. So one of the lessons we learned from this is that you can nest functions, or that you can, what is often called compose functions. That is to say, there's a composition, which is the sum collection of sub-functions, right? So here, this weight GL, which GL is for gain or loss, is composed out of the functions that represent calories consumed and the calories burnt. But as I pointed out to you a minute ago, that the calories burned are burned in two ways. One is through activity, and the other one is via the resting metabolism, right? So we write here that the weight gain or loss is a function of the number of calories consumed and the number of calories burned through activity and via the metabolism. Now be careful here in reading this equation. There's a parenthesis that opens at this point and it closes at this point. So, and note the minus sign here. This will multiply the terms inside these parentheses from here to here, right? So this sign will become negative when you fully write out the equation, okay? So the question is, how do we find out how many calories are consumed and how many are burned and how many are used up by the metabolism? Well, you can go to these links that I've provided to look up some of that information, right? And here in the calories consumed, it's important that you take into account everything that is consumed. So if you breakfast, lunch, dinner, any snacks in between, if you're drinking soda or alcohol, those contain calories. If the soda is sugared, and so forth. So all of the calories consumed. And then you can estimate how many calories are burned if you're exercising or walking or just doing the usual daily stuff. And then the calories burned by the metabolism. And all of that information can be obtained from visiting these websites. These are relatively reliable, so you may want to check them out. So now we're going to try and figure out some use for this function. I want to point out the use of this symbol. This stands for proportional to. Now, the reason I'm using proportional to is because I don't know myself, and I'm not sure if it's health science people know or not, the exact equation whereby the weight would be equal to this function and these after the appropriate operations, these functions. But we do know that the weight gain or loss is proportional to calories consumed and burned. So that's why I'm using the symbol here. It looks like an alpha, but it means proportional to. Okay? So not having a handle on how the exact weight in pounds or kilograms connects to the number of calories consumed, I'm simply going to use a simpler scheme, which is to say the net calorie gain in a day is the number of calories taken in minus the number of calories burned. So that's pretty simple, and that gives us this relationship. Now let's see where we can go with this. Okay. Remember example from week 3 with Mr. DV Jr.? Well, we can sort of work with that, but of course this can work for anybody. So what I've done is constructed a table here. Let's take a look at this table. I'll give you a moment to sort of assimilate it, and then I'll talk about it. So what we have here in this table is, I call it day number, but it just means that which day of the week or month or the elapsed time it is. So the first day you start making these measurements is day 1, and then 2, 3, 4, and 5, and so forth. Okay, here's the net calorie loss or gain, which is basically this side of the equation. That's what's represented here. So in order to get these numbers, I need to know what these numbers are back here, right? And by using the website, and in fact, this kind of information you can look if you buy packaged groceries, packaged as in cans, bottles, and so on and so forth, and even snacks. On the back of it is a table of calories contained within the food, and normally what's recommended, or not recommended, I should say, what is an estimate of the number of calories that a person should consume during the day. And it's typically around 2,000 calories. The K here stands for kilo, because while we call them calories in everyday life, they're actually kilocalories. So the unit calorie is actually smaller, and we talk about thousands of calories, okay? So this would become 2,300,000 calories, but let's not get into that right now. Let's just take the numbers as they're given. Okay, so somebody with Mr. DV Jr.'s weight and height my guess is would consume at least 2,300 calories per day. Okay. As I said, you can go to the websites and get a better estimate for your size and weight or anybody else's size and weight that you care about, but it's in the ballpark of 2,000. Okay. Now the calories burned in activity is, I'm just guesstimating it here because of this, right? The resting metabolism consumes about 1,800 calories. So if that's what's happening when you're not doing anything, then and you're consuming, let's say 2,000, you're burning only about 200. Which, by the way, that seems like a really small number. Really, is that all that I burn during the day? But it's really hard to burn calories, right? So if you've exercised and you can again go to these websites and look up the number of calories consumed in various or burned in various exercises and for how long, you may be surprised. Okay, that's why it's so easy to put on weight and really hard to lose it using only exercise. You've got to control both diet and exercise to manage your weight. Anyway, I just plugged in some numbers here because I'm more interested in explaining the concepts to you than in an accurate representation of a person. Here, so the number of calories consumed, let's see if we were talking about Mr. DV Jr., he got to camp, and at that point in time, his calorie consumption per day was about 2,300. And he didn't do much work, he just, no exercise or anything, so let's say just he lost about 200 calories in activities, and then his resting metabolism, let's say, consumed about 1,800. So this is over the course of a day. Got a night's sleep and then did some work during the day or not, as the case may be. And this is roughly what he burned. So then you, as his drill sergeant, put him on a training schedule. You said, all right, well, you're going to consume fewer calories and you're going to burn more calories, right? So his resting metabolism in the beginning is not going to be burning any different numbers, so he's still at about 1,800 calories per day. Over here, you made him do some more work, so he's burned about 300 calories, and you cut down on the amount of food he could eat. And so he took in or consumed only about 2,200 calories. So this here is, okay, you sum up all of these terms, remembering the minus sign, right? It's here, net calorie gain, calories consumed, minus calories burned through activity. And then remember this, both these terms are inside the parentheses. So this minus sign multiplies this plus sign to give you a negative sign again. So it's calories consumed, minus calories burned in activity, minus calories burned in metabolism. And here, on the first day, his net calorie gain was 300, right? And then on the next day, it was only 100. And because you really made him drill hard and sort of watched or what he took in and told him when to stop, I guess, he lost calories on the third day. So that is basically what we are saying and seeing here. Okay, so what we've gained from this is we have learned how to create functions that express the relationships or relationship between certain quantities. And the second thing we'll learn, sort of by happenstance, is how to construct a table showing or plotting out the values that go into the function, its inputs, and the value of the function as a consequence of the input, so that the result that the function evaluates to. Here is, this column is, okay, this column is what the function evaluates to, that is what is the result is, and here are the inputs that go into the function, these three columns over here, okay? So this is not bad. We can kind of see that, Mr. DV Jr. is losing calories as the days go by, burning more calories than he's taking in. And what do you think is going to be the impact of that? Right? I mean, his body is still metabolizing at a certain rate, and he's spending time working out, which is consuming calories. And those calories have to come from somewhere, right? Because he's not eating enough food now because you put him on a diet in essence, right? So those extra calories are coming from where? They're coming from within, or so to speak, from his body. His metabolism and his activity is burning up the calories that are stored in his body. Typically, this would be coming from fat. In starvation conditions, people also lose muscle mass, that. But right now, what you're trying to do is get Mr. DV Jr. to lose weight, which means lose the amount of fat that he has accumulated and actually gain muscle mass, because you want to toughen him up a little bit, right? And by putting him through this regimen, his body composition will change. The muscle to fat ratio will change. The amount of muscle, as expressed in, pounds, kilograms, or whatever, will go up. And the amount of fat expressed again and as weight in kilograms or pounds or whatever will go down. But the difference, so hopefully here he will gain muscle and lose fat, but in the process, he will lose more weight of fat than the weight of muscle he gains. So his overall weight will decrease. Does that make sense? You sure you're following that? So Mr. DV Jr. is taking in calories via food and drink. He's consuming calories. I shouldn't use the word consuming. He's burning up those calories through activity and his metabolism. And because he's taking in fewer calories through food and drink than he's burning up, the deficit has to come from somewhere, and it's coming from his body losing, hopefully only in this case, losing fat, because you're making him exercise and do things, so he's not losing muscle. In fact, he's gaining muscle, right? Those of you who are in health sciences or like going to the gym and working out and so forth are probably very familiar with all of this. Okay, cool. I mean, so tables are great. I think they serve a very useful purpose, But sometimes it's nice to be able to look at a graphical representation of the table or of the function or whatever relationship it is that we are trying to understand. So that's what we're going to do, okay? Now, I've given you a plot of the net calorie gain or loss per day, okay? And so we'll bop over to that plot and take a look. Okay, here it is. This is the same table as here, right? And so I'm discovering some limitations of Desmos. It can be really annoying at times. It wouldn't let me do the computation in here directly. Anyway, that's beside the point. The thing is, the points in Y in red represent the net calorie gain or loss, and here along the x-axis the number of days elapsed. So on the first day, he gained calories. There was a net calorie gain of 300 calories, right? And then on the next day, day 2, there was a net calorie gain of 100 calories. And on the third day, there was a net calorie loss of 100 calories, and then so on and so forth. So you can track these points down, and you can see that as the days go by, he is burning more calories than he's taking in. And you know what the result of that would be. He would be losing weight, right? And that's the intention of being in this camp, is to get him in shape so that he can enter the military and pass the fitness test, right? Okay, so I'm looking at the scatter of points, and yeah, okay, all right. I mean, it's sort of okay. It doesn't thrill me or anything, right? But note that the word that I used, a scatter of points, which is an accurate description of this, and it also actually then leads to the name of a plot of this type. This is called a scatter plot because the points are scattered on the plot, on the graph paper, right? So here's a scatter plot. Now we can do a little bit more with this. So take a look at this next thing. Well, before we look at this next thing, do you remember our week 3 discussion, right? And that's when Mr. Davy Jr. started the camp. And we had his weight plotted out here. This was weight. It's not net calories gained or lost. It was weight. And this was the scatter plot that we created, right? And then I said, okay, hey, how about trying to put a straight line through these plots? And if you remember, I think you still have the links. We mapped a straight line through these plots and tried to figure out by adjusting the slope, the line's down here somewhere, right? By adjusting the slope and the intercept to see if he would actually end up at the target weight of 180 pounds, right? So this is an okay exercise, and you can do this, and I hope that some of you did this. Sometimes I don't know if you actually go ahead and work with these things in the extent to which you work with them. But anyway, this would have been a good exercise, and I hope you did it. But now we're going to come back to our current week's exercise, and which is here. Here we have a scatter plot. It looks kind of steep simply because, I mean, this is one of the things that I find limiting about Desmos is it doesn't allow me to scale the axes independently enough, right? So I can't change the aspect ratio really easily. Anyway, again, here's a scatter plot of net calories gain and loss. And remember, here is what our scatter plot of weight gain or loss. And both are scatter plots, and I'm just showing these to you to sort of establish the similarity between the two kind of plots. And remember that we plugged a straight line down on the weight scatter plot, trying to figure out if we could get to the ending weight within the length of time. Remember the week number here, right? I've only shown you 7 days here in the plot we're working with this week, but this is the number of weeks. So down here, 2 weeks would be 14 days, and you can extend the table. I just figured I'd let you do that. Okay. So we go back to the plot for the current week. And this is net calories with the days elapsed. Now here's something cool. All right, we made up this line. Remember the last time we did this? I just plugged in the equation of a line and adjusted the slope, and we messed around with that. But this week, we're going to be a little bit more sophisticated. So I'm going to plug in a line here, and you can see another straight line, another through the plots, but there's something special about this line. Okay, what do you think is special about this line? I mean, what distinguishes this line from this line we fitted to the scatter plot? They're both straight, right? I mean, what else can a straight line be, right? So what's special about this line? So what's special about this line is that this is what is called a best fit line to this scatter of data points. There's some details about the best fit piece, but we don't need to get into those. I mean, if you become serious about this, you'll take courses and you will learn all about it. But in the meantime, it's enough to know that this is a regression line. The term for this kind of analysis is called regression or regression analysis. This line is a regression line that fits the scatter of data that you may have got from whatever source you used. Right? And this is the best possible straight line that you could fit to that data. Does it match the data points exactly? No, it doesn't. But it's the best fit in the sense that it gives you the least error between what you would learn from the line and your actual data points. So think about what I said for a minute. You may want to rewind and listen to it again, because I buried some information in there, not intentionally. It's that I just used a bunch of words and said something based on the implicit knowledge that I have, but you may not have. So what you can do with this line is that essentially you can go along the x-axis, pick a particular day, and then be able to estimate how many calories Mr. DV Jr. or whoever else would have lost on that day. Is that going to be super accurate? No, of course not. But it's going to be better than this line that we kind of fitted more or less arbitrarily. It's an okay line. It'll give you, here we were plotting the line against a scatter point or scatter plot of weights. And here we're doing calories consumed or lost. That doesn't matter. The y variable can be anything. The point is that in both cases there was a straight line, and we could use the straight line to figure out what the value of the second variable would be if we knew the value of the first variable. So if we knew that the ending weight was going to be 180 pounds, how long at this rate of weight loss would Mr. DV Jr. take to get to that weight? And we could read that off like 12 weeks. Well, he's not quite there, but you're going to make him work harder and get there. But here, there's no target per se, but you can figure out or set a target for yourself. Here, what you can do is you can say, okay, on day number 5, right, I am going to, here's this point, and maybe I should try my marker thingy again and see if it works. Let's just draw a straight line. So let's say we are, and use a different color, right? So let's say we are at, what shall we pick? Let's just pick day 5. All right, so we pick the x value at 5, and we drop down, and we say, okay, Mr. DV Jr. will lose, 200 calories on the 5th day, right? Is he actually going to do that? Maybe, maybe not. But based on the available data and fitting a straight line to that data, that is your best estimate of what he will lose on that day. Now, actually, he didn't do well on the 5th day, right? Because he only lost a little over 100 calories. But in general, you can see here that the line is representing how many calories he will use. And after a little bit of, come on, it's only been 5 days or 6, 7 days. It's going to take him a while to get settled into the routine. But now he's kind of on track over here at this point. So the idea is that you can use this regression line to get the value of let's call it the output variable or the function when given a value of the input variable. Now that's pretty neat. There are not too many ways where you can do that and have some sense of reliability about your computations. So regression helps us to do things like that. Okay. Now I want to point out one other thing. I'm going to fiddle with this annotation tool again and see if I can just highlight that for you in some way. So let's see here. One of the things to note is that the measure of the goodness of fit of a line is given by this quantity r square. I hope you can see that. Okay, it's just called the regression coefficient. Okay, now what's special about r square is its value. So if let's erase this and so I can get back to my pointer. And yeah, so what's special about r squared and its value is that the closer the value is to 1, the better the fit of the line is. That's why it's called a measure of the goodness of fit. If the value of r squared is 1, that's the best fitted line that you can get. And its value would be 1 if all the points, I mean, if it just so happened that all of these points fell on this line, or the line fitted all of the points exactly, right? If r squared is equal to 0, that means, yeah, there's no predictive power in the line. It's just, you can draw it at any old angle, at any old slope. It doesn't make any difference. It's not going to tell you anything. So if you happen to do regression, be aware of this, of this parameter r squared. This is called a tilde sign. It's generally used to indicate that approximation, right? But here, this is just Desmos's notation for creating a regression line. So if you were to type this thing in exactly, which I'm not going to do right now because it'll mess up everything over here, and then it'll take me a while to correct it. But the idea is here. So okay, if you write it like this, well, everything's disappeared because there's no x and y on this side. So we will just write it back and put this tilde sign. Now the tilde sign is in the top left corner of your keyboard. I don't know where it is on a phone. Sorry, I don't use phones for anything other than, would you believe it, talking to people, or at most sending text messages, but so be it. Anyway, on your computer keyboard, the tilde will be at the top left, to the very left of generally the row where the numbers are given. All right, so you can find this there. So if in Desmos, this is specific to Desmos. If you write an equation like this, what the tilde does is it tells the computer, that's where these graphs are being plotted and the data is being run, is that, hey, take my x and y values in the table and fit a regression line to them, a straight line here. All right, this is a form of a here to here. You recognize this. This is a straight line. So that's all. Now, what I would encourage you to do is you can plug in any different value here, right? I mean, you can change this table, or you can create your own table. You can, oops, that's a little too much, right? Even for Mr. DB Jr., right? And think about this, right? Maybe you can use this kind of approach for yourself, right? If you go to the gym, I know that at least one of you posted something about like going to the gym and trying to bulk up. Well, this works for that too, okay? I mean, right now we are making Mr. DB Jr. lose weight, but we could also be making him or somebody else gain weight. So you're going to the gym, you're burning up, remember our equation here, you're burning up calories and exercise, then you got to eat high protein stuff and all of that. So that you can gain those calories back, plus enough calories to build up the muscle that you want to build up, right? So you can do that. So use this function and this kind of approach and plot this out, and give you a nice graphical representation. Same thing, if you're trying to lose weight, again, go over here, build your table, plot this out, and you can say, oh man, if I'm going to go at this rate, I'm going to gain, or after 20 days or 18 days or what have you, I will have gained or lost this many calories. And again, remember I said earlier that I don't know of an exact equation that where you can put weight on the left-hand side and the calories consumed on the right-hand side and burned, of course, and have a proper equation where the two sides balance. So If you're interested, you can search on the net. I don't know if anything is there, but you can look, and you can look at those websites. But anyway, this will give you an indicator. And the other thing you can do is, of course, this doesn't have to be calories consumed. This is where you weigh yourself every day, right? So instead of calories, this would be pounds. So maybe you start out weighing, I don't know, 150 pounds. And, and X doesn't have to be days. You can think of it as weeks. And so the next week you're at 140 pounds and you say, no, oops, that's not what I want really. I want to be up. And so you do whatever needs to be done. And then in the third week, you're at 160 pounds and so on and so forth. Of course, you've got to adjust everything here, right, to whatever your target weight is or whatever your measured weight is, and so on and so forth. And I'm trying to plug all of this in so you can see, and the slope of this thing should flip around. It will, right? Because, looky here. Okay, now the line has a slightly positive slope. It's the best fit line to these data points. So let's say this was X was in weeks, and Y is in weight. So you can say, okay, I'm at 160 pounds in 7 weeks, and if I continue to gain weight, because I assume this is what you're trying to do here through exercise, continue to gain weight. In week 10, I will be, let's zoom in a little bit. In week 10, I will be 174 pounds roughly, right? Okay, so this gives you a sense of what you can achieve. Now, our goodness of fit of the line actually is now down to 0.42, which basically is saying here this is not such a good fit. Okay, I mean, it looks good on the graph, but mathematically it's saying it's an okay fit. This is not bad. All right. So the more data points you have, and the closer the real function is to a straight line, the better the fit is going to be, because it's fitting a straight line. You can fit other kinds of curves to a set of data points, but that starts getting complicated, and it's not very useful for our purpose anyway here if you're doing something like weight gain or loss. So I hope that was useful. Again, speed up the video so you don't have to listen to my ums and ahs, and have fun. See you next week. Bye.